Hello explorers and welcome to another video. Today we are going to continue building Linux. So next up we need to install tar and that we have used a lot here as well. We're using it now. So this will also remove something here. So in some case where we have an abort, we will actually put in a fall through instead in the extract. This will fix a bug that was introduced in this tar package 1.31. So if you're using another more recent guide, this might not be applicable. And then we will force unsafe configuration and we will configure the USR and bin directories. So that's what we are doing here. And force unsafe configure. This forces the test for make node to be run as root. It's generally considered dangerous to run this test as root user, but as it's been run on a system that is only been partly built, it's overriding this is okay. So if you are building this in a system which is fully built and everything is up and running, then you should not run this unsafe configuration command. But as we are continuing to build our system and trying to create something here, we want to run all the tests to ensure that we have something stable that we can work with later on. So tar is a command that creates, extracts files from and lists the contents of archives known as tarballs. So let's run make check and make install here. And these tarballs is actually a way to take a lot of different files in your system or directories and create a structure which they are calling a tarball. So they are writing just all the files and all the different information into one file with all the different file directories and other entries in a structure that can be then extracted again. So it's actually not something that will compress your data. It will just package them into one point. And this is good because then another program that is actually made for compressing information like gzip, bzip, all those other programs that are made more for compressing and decompressing files can be specialized in that task. So you have one that specializes in the task of creating structure within a file for your different directory and file entries, and then you have another program that does the actual compression. Then you can actually run tar and use libraries from the different compression engines, but remember, the gzip, for instance, is not actually a part of tar. It's another library that tar will use in order to compress your files. So that's the strength of a Linux environment, that you build one thing that does one task very well, and then you have another thing that does a similar task but might take help from the first program that ran and did something. In this case, it will create a tarball that someone later on can compress. So this will take 1.7 SBUs, so it actually will take a while for this to finish. So I'll get back to you when it's done. And we are done. Now we have built tar. So let's take the next in alphabetic order. Let's see, this is texinfo. Let's install textinfo. So what's up with that? So first we need to fix something that will actually create a lot of failures in the regression test. So let's just apply that fix. And then we need to prepare it with the prefix of USR and disable static, the normal thing that we want to build it against our libraries, not as a static program. So we'll reuse as much as possible in our Linux environment. So let's see when it's done here, and then we have the classical make, check, and install flow that we are used to. So let's see, textinfo package contains programs for reading, writing, and converting info pages. And info pages are used for our man pages, if I don't remember incorrectly. So the info we'll use to read these. We have install info, install the different pages and index them in our database. We have make info, which will translate plain text or HTML to info files. We can also create DVI or PDFs from different info files and so on. And so let's see here, we do a make check, and make install, our standard programs that we usually run. And this is 0.9 SPUs. So I will wait and get back to you when it's done. And we are done with the text info. So let's continue. Now, next up, we need to install Vim. And if I have ever edited a file in Unix environments, I will use VI, which is a powerful text editor. It can be a hassle to learn how to use it, but once you can use it, you will use it regularly. So first we need to change the default location of vimrc to etc. So we'll do that there. Then we use the standard configuration script here with a prefix of USR. Let's see here. What can we say more about this editor? Yeah, we will get the EX command, which will start Vim in the EX mode. We have VI, which is just a link to Vim. View, which is a read-only version of the Vim. We have the text editor of Vim. We have Vim diff, which will edit two or three versions of a file with Vim and show the differences. So let's see here, the make command is next up. The tests are a little bit more involved, so we will wait with those. This is 1.3 SPUs, so it will take a little bit of time. Then we have the Vim tutor, which teaches you the basic keys and commands of Vim. That one I will need to run sometime to actually learn more of these, because I've used Vim a lot, but I'm not very proficient in it. Create hex dumps of a given file. So XXD will create hex files of a given file. Interesting. And we also need to do some configuration of our Vim installation later on here to get it more useful. By default, Vim runs in VI compatible mode. This may be new to users who have used other editors in the past. Non-compatible settings is included below to highlight the fact that new behavior is being used. It reminds those who would change to compatible mode that it should be the first setting in the configuration file. This is necessary because it changes other settings, and overrides must come after this setting. Create default Vim configuration file by running the following. Yeah, so we will do that later. And we'll look at what we actually will create. Yeah, so this is interesting. I will wait for this to complete and I'll get back to you. Yeah, so there it was done. So next up, we need to figure out how to actually test this. And then we will run this, where we will set that the language we are using is ENUS, so English United States, with the UTF-8, so that's the character encoding. We will run it not in parallel, we will run all the tests, and we will pipe that out to a Vim test log file. So this will take a while, and it does a lot of output of binary data to screen, and this will cause issues with the settings of the current terminal. The problem can be avoided by redirecting the output log file as shown above. A successful test will result in the words all done in the log file at completion. Okay, so I guess that we will grep for all done when the tests have run. I wonder how long that they will take. Doesn't really say. I'll get back to you when they are done. So the tests have ran. So let's see here. We can grep for all done in the Vim test log. And we got the all done in that file, so that means that the test actually passed. So let's make install. I believe I didn't type that correctly. So now we have installed Vim. And then we need to make a little bit of a link to VI from Vim. And we also need to go through and symlink the different languages. Okay. Not sure if we actually needed that, but now we have done that. So all the different documentation is also symlinked, and we need to do a documentation link here to link from one documentation directory to another. Then we need to create this vimrc command file here. So let's see here. We have changed over to skip the defaults of Vim. We will run it non-compatible. We will run with a backspace of 2. We will set the mouse to syntax on. Set mouse to nothing, syntax on. We will check if the term is xterm or putty, and then the background will be dark. So that's the changes that we have done. Set backspace to 2 sets, allowing backspacing over line breaks. Yeah, that's good. Syntax on is syntax highlighting. Set the mouse will enable a proper pasting of text with the mouse when working in zero or over a remote connection. Yes! And we will also set the background to dark if we are running in a terminal. Yeah, those are all good. I like this one. Documentation of other available options can be, if you run the vim-c :options, you will get the other options. Or if you're in Vim, you can type :options and you will get those options there. You can also set a language if you like. I'm not going to do that. So now we have installed Vim as far as I'm concerned. So let's do the next one. This is procps-ng. And this also needs a lot of different configuration options here. So let's paste that. So we have the prefix of USR, we have the XX prefix, which we will set to nothing. The libdir is USR lib, docdir, we set that. Disable static, we know that, and disable kill. So disable kill is a switch that disables kill command that will be installed by the Unix Linux package later. So this actually contained a kill command. So procps-ng package contains programs for monitoring processes. Is this the one that contains PS perhaps? That's really interesting if that's the case. Let's see. Yeah, so PS is the one that you will use to list the current running processes. That I use a lot. Then we have top, which will show you the top working processes, so the processes that uses the most CPU memory and so on. And uptime will show you how long you have been running. Watch is also a very good program. Let's see here. Next up for the test suite here, we need to actually run some sed commands here. Remove test that fails when scripting does not use TTA iDevice and fix 2 other tests. Yeah. So we'll remove some tests and fix some tests here. And then we can run make check on those. So watch is a very interesting command because when you are running watch, so those were done already. Make install. The watch command. Okay, I will complete these. So we'll copy some of the SO files over from USR lib to lib, and we will also create links back to those again. So the watch command that I was talking about here is a command where you can actually type watch, and then any command after that, usually you use some colons or some kind of thing to actually contain this command inside of the watch command. So it's only one argument to watch. But if you give watch an argument of another command, that means that the watch command will run that command every 2 seconds. This means that you can type a command that will give you some output. For instance, how many lines are there in my log file? And it will watch that every 2 seconds. You can see when the log files actually is written, you can see the commands coming in and see how it grows. Or perhaps you want to run a command that creates a lot of files in a directory. Then you can list the files in the correct directory and then count them with VC and then see as they grow and when they are actually completed, when all the files are in there. So watch is very interesting. I use that a lot in my daily work. I think I will stop here. And this video will be cut into smaller parts. So this will be multiple videos, and I hope that these videos in this series will help you learn a little bit more about the Linux environment, what goes into the Linux environment, what kind of tools and libraries you can find in a Linux environment, what you can do with the Linux environment. If you have any questions about Linux, leave them down in the comment section down below, and I'll try to answer them as to my best knowledge. If you like this video, give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that. And I really hope to see you in the next video.